to 0. We're going to leave 8x squared here. We are going to bring 40x over by adding it to both sides. We are going to bring 48 over by subtracting it from both sides and set the whole thing equal to 0. This is a problem that can be factored. If you look, each one of these terms is divisible by 8. If you factor out an 8, you're left with x squared plus 5x minus 6. And the trinomial can be factored further to x plus 6 times x minus 1. And that is all equal to 0, which means that x is either negative 6 or positive 1. Number 7, again, you must set equal to 0. This, however, is not a problem that can be factored, so we're going to use the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. b is already negative, so it becomes positive 16 plus or minus 16 squared, which is 256, minus 4 times 4 times 3 all over 2 times 4. Four times 4 is 16 times 3 is 48. 256 minus 48 is 208. And 2 times 4 is 8. 208 is 16 times blah blah 3. No. Excuse me, 16 times 13. Yes. And 16 is a perfect square, so you can take a 4 out from under the radical. You're left with 13. And because all three of these whole numbers can all be reduced by 4, then we're going to reduce them by 4. And so we get 4 plus or minus the square root of 13 all over 2. Because this problem is an equation, you do not have to deal with the fractions. You can actually get rid of them. And the way we do that is by first factoring anything that can be factored, finding a common denominator, and multiplying everything by that common denominator, which means this first fraction would be 1 times x plus 3, x minus 3, over x minus 3. The second fraction would be 2 times x plus 3, x minus 3, over x plus 3, x minus 3. And this third fraction would be 5 times x plus 3, x minus 3, over x plus 3. Now the point of doing this is to be able to cancel or reduce those fractions and make them whole. X minus 3's cancel here. All of this cancels here. And x plus 3 cancels here. So we're left with 1 times x plus 3. 2. And on the other side of the equal sign, 5 times x minus 3. And no more fractions. If you subtract x from both sides, 3 plus 2 is 5. This is 4x minus 15. Add 15 to both sides. 4x is equal to 20. Therefore, x is equal to 5. From the very beginning, if you look here, x could not equal 3 or negative 3, and it doesn't, so we are fine. This is an evaluation problem. 4 cubed is 4 times 4 times 4, plus this negative is in the parentheses, so 3 squared is 9. Anything to the 0 power is 1 because there's a minus sign in front, it's minus 1. And a negative exponent means that you are to flip this and raise it to the 4th power, so it's 2 to the 4th power. (64) plus 8 plus 16. 6 plus 4 is 10, plus 8 is 18. That's 7, okay, is 88. Number 9 was 88. Number 10 is to simply simplify the fraction. You can't get rid of the fraction, you're going to simplify it. So we're going to factor, restrict, and cancel. The numerator, to begin with, you can factor out a 2 and an x, which leaves you with 9x squared minus 4. This can be factored further to give you 3x plus 2 times 3x minus 2. The denominator is a trinomial in which the first terms must multiply to give us 3x squared, and the last terms must multiply to give us 2, but when we subtract the product of our inner and outer terms, we must get -1 in the middle, and this is what you get. We have factored. Next, we're going to restrict. X cannot equal -2/3 or +1, and then we are going to cancel what can be canceled. So here was your final answer. Number 11 is a fraction that contains a radical in the denominator, and since the denominator is not completely under a radical, the only way we can eliminate it is to use the concept of the difference of two perfect squares and multiply by the conjugate of that denominator. But what you do in the denominator, in order to keep the value of the fraction the same, you must do the same to the numerator. In the numerator, when I do FOIL, I have 1 times 1 is 1. My outer terms, 1 times negative square roots of 8 is negative square roots of 8, which is this. My inner terms give me negative square root of 3, and last times last is positive square root of 24, which is this. I'm getting ready to reduce. That's why I'm separating into perfect squares and not. The denominator, first times first, is 1. Outer and inner cancels. That's the whole point. And last times last is -8. So, simplifying here, in this second radical, I can pull out a 2, because the square root of 4 is 2. This cannot be reduced. The square root of 4 here is 2. 6 is the product of two prime numbers, and my denominator is a -7. In the numerator, none of these radicals are alike. You cannot add them together. But if you notice here, I have a negative in the denominator of my fraction, which is not proper. So in order to turn this into a positive, then I will change all the signs of every term in the fraction. So this becomes -1 plus 2 square roots of 2 plus the square root of 3 minus 2 square roots of 6 over positive 7. Number 12, we are asked to subtract radical expressions. You can only do so if they're alike. Right now they don't look very much alike, but if you break them down, 18 is 9 times 2, and 50 is 25 times 2. 9 is a perfect square. 25 is a perfect square. Now you see that your two terms are indeed alike. They both are the square root of 2, and we're simply asking 3 minus 5 is -2 square roots of 2.